Hello everyone, this presentation is authored by Reddy Prakash in the field of machine learning and data science. The project focuses on one of the most critical businesses challenges in the banking sector, customer churn. The work combines data analysis and predictive modeling to help banks identify customers who are likely to leave, enabling timely intervention. Now we discuss about the problem statement. In the banking industry, customer churn refers to the phenomena where a customer decided to stop using the bank services and closes their account or moves to the competitor. This is serious concern because researchers shows that acquiring a new customer costs 5 times more than the retaining an existing one. Therefore, early identification of at-risk customers is far more cost-effective than trying to win them back after they have already left. The goal of this project is to build a system that can predict churn before it happens, giving the bank enough time to take preventive measures such as offering personalized deals or improving customer service. The solution is a machine learning based prediction, system learning based prediction that analyzes customers' behavior and flags those who are at high risk of leaving. Now we see the data set overview. The data set used in this project contains records of 10,000 bank customers from the three European countries, France, Germany, and Spain. Each record includes several important features such as the customer's age, account balance, number of products held with the bank, and whether they are an active member or not. The target variable is column called excited, where a value of 1 means the customer has churned and 0 means they have been retained. The data set reveals that approximately 20.4% of customers churned, while 79.6% were retained. We will see in the here we see in the PPT. Indicates a class imbalance that needs to be carefully handled during model building. Now discuss about the methodology. The project followed a structured 4-step methodology to ensure reliable and accurate results. The first step was data cleaning and pre-processing, where missing values were identified and handled, and outliers were treated so they would not distort the model's learning. The second step involved exploratory data analysis of EDA, where visual tools and statistical techniques were used to discover patterns, trends, and correlations among the features, helping to understand which factors are most associated with churn. In the third step, 4 machine learning models were trained: logistic regression, decision tree, random forest, and XBoost, to compare their performances and determine which works best for this problem. Finally, hyperparameter tuning was performed using grid search CV, a technique that systematically tests different combinations of model setting to find the configuration that delivers the highest accuracy. Now we see the model results. After training and evaluating all 4 models, the results clearly showed a progression in performance. Logistic regression achieved an accuracy of 80.2% and decision tree performed slightly lower at 79.5%. Random forest, being an ensemble method that combines multiple decision trees, significantly improved performance to 86.2%. The best performing model was XBoost, which achieved an accuracy of 86.7% along with an AUC ROC score of 0.89. The AUC ROC score is a key metric in classification problems. A score of 0.89 indicates that the model has a very strong ability to difference between churned and retained customers, making it the most suitable model for deployment. Now we see the live demo. To make the project practically useful and accessible, the trained XBoost model was deployed as the web application using Streamlit, a popular Python-based framework for building data science apps. The application is hosted at FindRaksha Churn Analysis Streamlit app. Here we see that and allows our user to input a customer's details in real time and instantly receiving a prediction on whether the customer is likely to churn or not. Here we see the churned graph and retained graph and high performances. That all we all see in this page. This transforms that machine learning model from a static experiment into a real-world interactive decision support tool that bank staff or analysis can actually use in real world. What I learned in this project, I will share with you. This project offered several valuable learnings experience across different aspects of the machine learning pipeline. Data pre-processing and future engineering taught the importance of cleaning raw data before feeding it into a model, as poor quality data leads to poor predictions. Comparing multiple machine learning models provided hands-on experience in evaluating different algorithms and understanding their strengths and weaknesses. One of the most critical learnings was handling imbalanced data. Since only 20.4% of customers churned, the dataset was imbalanced. The smooth synthetic minority oversampling technique was used to artificially generate more samples for the minority class, helping the model learn both classes more fairly. Finally, the project also covered machine learning model deployment, where the trained model was packaged and served through a streamlined web applications, bridging the gap between data science and real world usability. Now we see the conclusion of this project. The project successfully demonstrated that machine learning can be effectively applied to solve a real and pressing business problem in the banking sector. The XBoost model emerged as the best solution with an accuracy of 86.7%, and the analysis confirmed that age, number of products, and member activity are the three strongest indicators of customer churn. From a business perspective, this system serves as a proactive retention tool. Instead of reacting after a customer leaves, banks can now anticipate churn and take preventive actions such as a personalized outreach, loyalty rewards, or service improvements. The overall impact of the project illustrates how machine learning is not just a academic exercise but a powerful instrument for solving real world businesses challenges. Thank you. The final wraps of the presentation with links to the project resources. The full source code is available on GitHub at Reddy Prakash Fine Raksha Bank Churn Analysis, and the live interactive app can be accessed at the Fine Raksha Churn Analysis Streamlight app. The project sits at the intersection of machine learning and data science, showcasing on end-to-end pipeline from raw data to deployed functional prediction system.